Sorry, I didn't start it on time. So the zinc in 1.20 grams of a sample of foot powder is this particular formula. Strong heating it of the precipitant yield this many grams. Calculate the mass percent of zinc in the sample. So we're going to start with the 0.4089 of the zinc. We're going to divide by the molar mass, which would be 304.7. We see that for every 1 mole of the zinc, I forgot the N in there, NH4, PO4, there it yields this product right here, which has 2 moles of zinc. So we would say 2 moles of zinc. And then I'm running out of room, but then we would multiply by the molar mass of zinc, which would be 65.37 grams per mole. And we would get that there would be 0.1754 grams of zinc.
In the beginning, why is it not 0.4089 grams of that zinc to E2?
It is. I did it wrong. I did it right on my paper. You're right. I can fix that. Yeah, sorry about that. I need to actually look at my paper, huh? It's the reason I do it before I do this, and then I didn't even look at it. Sorry about that. I'm glad you caught that, because then if you hadn't, it could have confused people later. Thank you, thank you. All right, so that gives us that we would calculate to be 0.1754 grams of zinc. So if we divide by the total sample, we could get the mass percent. And then multiply by 100. So we should get 14.62% zinc in the sample of foot powder. Okay, any questions on that? This is sometimes what throws people off, because the stoichiometric relationship is not from a balanced equation. It's from the fact that we have right here, we have 2 moles of zinc in 1 mole of the compound. Does everybody understand that? Okay. Is anybody still writing? Okay. Got it? Okay. In the next problem, it says a mixture of sodium chloride and iron 3 nitrate is mixed together, and it's filtered and dried, and its mass is 0.125. So it wants to know, first of all, the mass of the iron. Okay, so if we have 1.28 grams of iron 3 hydroxide, okay, molar mass is 106.9. For every 1 mole of the iron hydroxide, we have 1 mole of iron. And then we multiply by the molar mass of iron, which is 55.85. I need to learn to write smaller on this thing. That ends up giving us 0.0669 grams of iron. And so then we can say 0.0669 grams of iron. We probably could have stopped at this mole ratio here, but I I wanted y'all to see the process. We would divide by the molar mass of iron to get it back into moles. But again, you could have done this all as one step if you wanted. And say 1 mole. And then for every 1 mole of iron, we can make 1 mole of iron 3 nitrate. And then we would multiply by the molar mass of that. And I'm going to let y'all catch up, and then I'll erase and finish the problem because I'm running out of room. That should come out to 0.290 grams of... Alright, here is what it should look like. If you're still working, don't look up here yet, but I'm going to go ahead and unfreeze this and let you see it. This is what you should have got. Any questions on that? Number 2 is the one that you had to remember what I said about forming sulfurous acid. What does it do immediately upon forming? Breaks apart to water and SO2. So, oh, I forgot to put the little S down here because this is a solid. Okay? So that is where we're going to stop the notes for today. Yes?